Hello children and welcome to your channel Sharda Educare, and in this video today we will be learning angle bisector theorem. Before we proceed for the angle bisector theorem, we will be performing an activity. Let's begin with this children. Children, I am going to draw a triangle and one side of the triangle is 7. I will be taking the protector and marking an angle of 60 degree. Now join it. So this angle is of 60 degree children. Let us check it. Yes, exactly. See, its initial arm is coinciding with this and the final arm is here. So we have got a 60 degree angle. Let me take this side 5 centimeter. This is 5 centimeter children, and join this. So this is my triangle ABC, where angle B is equal to 60 degree. AB is 5 centimeter. Let me again take the, yes, it is exactly 5 centimeter children. I hope you can see it clearly. BC, let us see, BC is 7 centimeter. So AB is equal to 5 centimeter and BC is equal to 7 centimeter. Now I will be bisecting the angle B. For bisecting the angle, I will keep the pointer of the compass on the point B and give an arc. Now keep the pointer where the arc intersect line BC and give an arc here. Keep the pointer where the arc intersect line AB and give an arc here. The point where both the arc are intersecting one another, join that. This point and B. So this is your point D, where the bisector is cutting the line AC. Now as you know, AB is 5 centimeter and BC is 7 centimeter. Let me draw it properly children. Yes, this is the line here. Yeah, exactly, passing through the point B. Now we already know AB is 5 centimeter and BC is 7 centimeter. Let us measure AD. So AD is 2.5 children. See exactly, it is 2.5 centimeter and DC is 3.5 children. See, 1, 2, 3, 3.5, 3.5. So let us write it here. AD is equal to 2.5 centimeter and DC is equal to 3.5 centimeter. Now I'll be finding the ratio of AB upon BC. Now AB upon BC. AB is 5 centimeter, children, upon BC. BC is 7 centimeter. Now find the ratio of AD upon DC. AD upon DC. AD is 2.5 and DC is 3.5. So we get here point and point goes away and you get 25 upon 35. See why it went away? Because here the decimal is after one digit, here the decimal is after one digit. So they get cancel each other. How will they get cancelled? See, if I want to remove the decimal here, I will write here 25 and upon 10. And if I want to remove the decimal from denominator, I will write 35 and 10 in the numerator. So 10 and 10 get cancelled and finally you get 25 upon 35, which I already wrote here. This is the way the decimal point will cancel. Now 25 and 35 will cancel by 5. 5 5s are 25 and 5 7s are 35. So AD upon DC what we got is also equal to 5 upon 7. So let me write here AD upon DC is 5 upon 7 and AB upon BC is also 5 upon 7. This is the first statement and this is the second statement. So what we come to the conclusion? We come to the conclusion that AB upon BC is the is drawn from one of the point to the third side, then that line will divide that side in the equal proportion of other two sides. Let's see with the theorem, by proving it with the theorem. So angle bisector theorem, we saw the activity before this, and what does the statement say? The bisector of an angle of a triangle. So let me draw a triangle here. This is triangle A, B, C, which we drew it in the activity. So bisector of an angle of a triangle. Let me take the bisector. Line BC at point T. So AD is a bisector. The bisector means this of an angle. Which angle? Angle A. Of what? Of the triangle. Okay. Divides the side opposite to the angle. Which side is opposite to this angle? This is angle A. And which side is opposite? Yes, BC is opposite to this angle. Na? This is the angle here and opposite to this is side BC. So bisector of the angle divide the side which is opposite to this angle in the ratio of the remaining side. Which are the remaining side? This is one side. So remaining side is AB and BC. So this bisector will divide this side in which ratio? In the ratio which is equal to the remaining side. AB and AC are the remaining side. So what is given? Let's begin with that first. Given angle A bisector is AD. AD is the angle bisector of angle A. What we need to prove? To prove is BD upon DC is equal to AB upon AC. This is what we want to prove, children. So let's start. So given is angle A, bisector AD, I wrote this side children, and to prove is BD upon DC is equal to AB upon AC. So let me do a construction. I'll draw a line, and this line is parallel to the line AD. I'll draw the line in such a way that this line is parallel to the line AD. Yes? Draw line C, extend line C such that it is parallel to AD. Let me name it as L. Draw line L such that line L is parallel to AD. Okay, means line L is parallel to line AD. Fine. Now extend BA in such a way that BA will cut the line L at point M. Okay, this is your line L children, and I extended BA so that it cut the line L at point M. Now let's begin. Solution here. AD is bisector of this angle. So this angle and this angle will be equal children. Means if this triangle A, B, C is cut by line AD, then this angle will be equal to this angle. So I can write like that. Angle BAD is equal to angle DAC. First point, angle BAD is equal to angle DAC. See children, how to write it? I want this angle in the middle. I want this angle, see, this. So from here to here, so this side I should take. That is BAD. Okay, BAD is equal to what? This angle. So DAC. So A should always come in the middle, and these two sides. Okay, BAD is equal to DAC. Why? AD is bisector. AD is bisector. Children, you can see one triangle, paper triangle I have drawn. If I draw a line in the middle, this line is the bisector of the angle, and if I cut it, bisector means cutting. Okay, suppose I am cutting this. So what would happen? This triangle which I got, this angle, okay, and this angle, they will exactly coincide on one another, see, covering one another. That means they are equal to one another. Yes, means one big angle, this big angle got cut into two equal angles, and if I keep on one another, they completely cover each other. That is angle bisector. See, they are covering each other. So BAD, when you cut in the middle, this angle will coincide with the other angle. Now only you saw. So angle BAD is equal to angle DAC, and we have, because AD is the bisector, we have already drawn the parallel line, children. If I say AD is the line let's say AD is parallel to MC. Reason, construction. We have constructed it, therefore it is parallel. When AD is parallel to MC and if MA is a transversal, children, see, AD is parallel to MC and AMB is a transversal, then this angle, let me draw here, this angle is equal to this angle. Okay, which angle is this? Corresponding angle. So we have written AD is parallel to MC and AM is a transversal. AM is transversal. Then angle, this angle BAD is equal to AMC. Angle AMC. Which angle it is? Corresponding angle. This is second statement and this is third statement. Now fourth. When AD is parallel to AMC and AC is a transversal. Now what we are going to take? AC is transversal. Now AC is transversal. See children, now AC is transversal and AD is parallel to MC. You get a Z here. Okay. This, you will get this Z. So this angle will be equal to this angle and that is alternate angle. So angle DAC is equal to angle ACM and this is alternate angle. You understood children? This is forming a Z, AC is a transversal, so this angle is equal to this angle. This is your fifth statement. Now you look at this children, this angle is equal to this angle is equal to this and these two angles are already equal to one another. So what can we say about this angle and this angle? They will be equal to one another because this one is equal to this and this angle is equal to this angle and this angle is equal to this angle. Therefore, these two angles will be equal to one another. So we can say this angle, how to name this angle? ACM. Therefore, angle ACM is equal to AMC. Angle AMC. See, BAD is equal to AMC, DAC is equal to ACM and BAD is equal to DAC. Already we have proved here. That is first statement, third statement and fifth statement. So ACM is equal to AMC by first statement, then third statement and by fifth statement. So we got this angle equal to this angle. Now this is your triangle and base angles are equal. Suppose I draw a triangle here and this angle is equal to this angle. So what can you say about this side and this side? These two sides will be equal to one another because base angles are equal. That is converse of isosceles triangle. So I can say now in my seventh point, this is my sixth point. In my seventh point I can say side AM is equal to side AC. And why? Converse of isosceles triangle. Converse of isosceles triangle. Now children, this side is parallel to this side, and when I am talking about this big triangle, now what will I write? Let me write this here, corresponding angle. And here let me write alternate angle. Okay, so draw a line here. Now in triangle BMC, AD is parallel to MC. Construction, because I have done construction, so it is parallel. Therefore, BD upon DC is equal to BA upon AM. And why it is like this? By BPT theorem. Means in BPT theorem, if this is your triangle and this line is parallel to this, so this side upon this side is equal to this side upon this side. So this line is parallel to this. So this section upon this section is equal to this section upon this section. So we got BD upon DC is equal to BA upon AM. Now look at the figure children, BA is equal upon AM. But here we have got AM is equal to AC. Yes. So in place of AM, I can write AC. So in the next statement I will get BD upon DC is equal to BA upon AM. In place of AM I will write AC. So what we got? BD upon DC is equal to BA upon AC. That is what we wanted to prove. Hence proved. So if a line is drawn which bisect the angle, it will divide the third side of the angle in one ratio, and that ratio will be equal to the ratio of other two sides, ratio of remaining side. Hence proved. You can pause children, you can rewind and you can watch the video and learn it. Thanks for watching children. We will continue further in the next video. Share, like, subscribe.